Hello, everyone. It's my pleasure to welcome you to another webinar in collaboration between the Australian Water School and TUFLOW today. And today's session will be on hands-on model running with automation. We have over 800 people registered today, over 54 countries. So yeah, thanks for joining us today. I'm Phil Ryan. I'll be chairing the session today, and which will be presented by Jaap van der Veld, and we'll be also joined by our panelists Abby and Shuang, who'll be answering the questions on the Q&A chat. We'll endeavour to get all of those questions answered today, either on the panel or during the session, but we also will provide a completed question list and possibly even some files in the next couple of days, I believe. I'll get Jaap, Abby, and Shuang to give us a brief introduction to themselves.
Yeah, thanks, Phil. My name is Jaap van der Velde. That's a Dutch name, and that's because I'm from the Netherlands originally. Been living in Australia for almost 10 years now and working for BNT. And the last several years of those, I've been working with the TUFLOW team. My background is in computer science. I'm a software engineer. I've filled many roles, and I work as a software engineer for the TUFLOW team. And I've got a passion for software, and that's why I'm presenting on this subject.
Excellent. Thanks, Jaap. Shuang?
Hi everyone, my name is Ron. My background is hydraulic engineering, and I've been working as TUFLOW developer for 7 years. Related to this webinar, my experience in automation includes some like writing batch file to run TUFLOW, which of course we do on daily basis. And I also write Python script to automate TUFLOW code regression test and also like TUFLOW model parameter calibration. So hopefully I can help answering a few questions in the background today. Thanks.
Excellent. Thanks, Shuang. Abby, are you there?
Yes, right here. My name's Abigail Lilo. I'm part of the support and training side of the TUFLOW team, and my background is in consulting for flood modeling. And I'm keen to discuss how automation can help with efficient project delivery. Thanks.
Excellent. Thanks, Abby. Let's take a quick look at the polls there. That should have popped up on everyone's screen. Looks like majority in the commercial consulting sector, with a few in academic and government as well. Excellent, and similar with a mix of modelling software. TUFLOW being the dominant, with the HECRAS following closely following behind. More in the experience in the running automation, looks like batch files, PowerShell and Python are the leaders in that field. Anything in there surprise you yet?
I think that's on the mark. I was more surprised by the relatively high number of other modeling softwares. I'll warn people that I'll be talking a little bit more TUFLOW than usually today. Then again, I still think everything I have to say is going to be very broadly applicable. So I shouldn't be scaring people off, I guess.
Excellent. And AI for modeling automation, it looks like 77% in the no category, but interested in to start using. Right.
Yeah, that is surprising, actually. I realized only when I was looking at the poll just now that another question that I would have been interested in knowing the answer to is what text editors people would have been using. Now, don't start spamming the chat, but I'm really curious on what people use for their modeling. So if a few people are really keen to share later on during the Q&A, that would be helpful.
Excellent. Thanks for that. And with that, I'll actually throw across to you. Take it away.
Yeah, thanks, Phil. All right, let me start sharing my screen. Right, so some of you may have seen last year's efficient model running with automation, surprisingly similar subject, perhaps, or maybe not that surprising because we had a lot of feedback on that, good feedback, but also people asking for more. So that's partly what we're here for today. Already quickly introduced myself. I think the current presence of AI, and I would say almost say omnipresence of AI, is an additional reason to want to follow up on this subject. I feel like now that AI is becoming mainstream, it's really putting software writing into the hands of most people that want it. I noticed that a lot of people say they're not using it yet. You'll find that I'm an advocate for it. Not a scaremonger. I also don't think it's going to take over the world or make life into nirvana. That would be great, but I don't believe it. I do believe that it's an incredibly important tool for software engineers, and it's an incredibly important tool for anyone who has anything to do with software or wants to make some of it. And automation is a lot about making small bits of software. I'm not a fan of the guy in general, but the quote is undeniably very good. Jensen Huang, the guy from NVIDIA, said, software is the language of automation. And I agree. Software is the language of automation. And in speaking about automation, I'll mostly be speaking about effectively software and programs and how they actually work. So let's get into it. The reason to follow up, especially what I just said, the impact of AI and the fact that there were quite a few questions that left unanswered, some stuff on the table after last year's. I do recommend going back and looking at that. If you feel like I'm skimming over certain subjects in this talk, it's probably because I already covered it last year and I don't want to repeat myself too much. I will offer a brief recap of what we talked about last year. Be really brief. Then I'll go into a little bit more deeply what role I think AI can play and should play. Then I'll really dive into console applications in the command line interface with some clear examples. Some of the feedback we got last year is people would like to see a few more examples. So we heard you. So I'll be doing the one thing you should be doing, which is showing stuff live. And then once I've covered that, I'll be talking about how to apply automation to model running specifically. So the whole process of it from start to finish. And then at the end, I'll have some tools and tips if there's still time left. And then we'll get into your questions and answers. I do want to invite people to feel free to ask any question. If you feel like it might be a little bit off the beaten path, we'll do our best to answer all those questions after as well. And so if you think of something during the talk and you're not sure whether it's directly relevant, I'm happy to see those questions. It's interesting to see what people think about. So the motivation for automation in general, why would you want to automate at all? Since you're all here, I don't think I will have to convince you, or at least I know you're curious. But a key thing, of course, is to save time. You want to maximize your runtime on hardware. You want to maximize your runtime on licenses. And you want to minimize the amount of time that people have to spend on doing stuff that could easily be automated. So it's about efficiency, clearly. It's not just about saving time. It can also add quality and resilience. And it can help in fostering collaboration, aiding collaboration. The important thing there is that once you automate a process, it becomes consistent, repeatable, and reproducible, which means that it's the same every time. You can do it many times again. And if someone asks you to do something again, what you did before, you can go back to that exact instance and do it again. It works the same time every time, no matter who runs it or where you run it. And that's very important. Do note that at the top, it says when done well. Obviously, in the end, it's down to the quality of what you write and the quality of how you manage it. So I'll be talking about that a little bit as well. Automation is scalable when done well. And that means once you get it to do one task, it can do over 1,000 with little extra effort. And importantly, it can do the same task over and over. And that's why it's often worth it to spend a little bit more time on writing good automation instead of just trying to get this one project over the line and then worry about more automation next project. Makes a lot more sense to write something that becomes reusable and put in a little bit more effort for that. Especially when you do that, the scalability argument becomes true. I'm sure that everyone has, I guess about 75% of you have a lot of experience writing batch files. A lot of those batch files get rewritten or copy-pasted and then edited. That's fine, but it only gets you so far. And part of the aim here is to talk a little bit more about how you could take that to the next level. and beyond, I'm sure. Finally, when done well, automation is documented and versioned. If you do a really good job on a project and the results are great, that's wonderful. That's job well done and bills paid. But unless you documented it really well, describing what you did, it's going to be hard for someone else to redo it. When done well, automation helps you to very in great level of detail document what it is that was done, and it allows you to version it as well to show how what you were doing has changed over time. And I think that's an important benefit of automation that's often overlooked. None of this is new. This is what I talked about last time as well, but I feel it's a little bit reframed. The other points that were made, and this is going to be even quicker. A point I tried to make last time, but didn't point out explicitly, and I will now. Engage with your IT. I realize that some of you might be your own IT. That's fine. Engage with your IT side. Don't just view this as a part of model running. This is a part of IT. Understand your problem well enough that you can explain it to your IT staff. I find that across the board for many organizations I've had contact with, IT doesn't really know what modelers are up to, and modelers don't really know what IT can do for them. There's real benefit in making the approach, understanding the software you use and how it could be more powerful, or how it could be used better if only you had better IT solutions. You don't have to become an IT expert, but you do have to extend a hand and make sure that IT understands what it is you're doing. Try to balance what you can handle with what you're allowed to use and what you expect from it. Like those three kind of get in each other's way. What you can handle depends on how complicated the software can be that you want to write or that you can maintain once you have written it. And even if you can write it, let's say you're an amazing Python coder, if your IT environment in your own business, or perhaps in the business of the client for whom you're writing a solution, if they're not allowed to use the product you're writing, then it's kind of pointless to make that effort. Or the problem becomes getting it to run somewhere instead of people just using it. It's one of the reasons why in the rest of this presentation, once we get onto the nitty gritty, I'll be focusing a lot on PowerShell, not because I'm a massive fan. I don't mind it. I think it's a lot better than what we used to have in the Windows environment, but mostly because it's available everywhere. And I think it's a very useful platform to start off of when you're looking at automation. And what you expect it to do, I feel like Einstein's quote there, or at least Einstein is rumored to have said this, everything should be made as simple as possible, but no simpler. That's the way to approach automation. Try to automate it, but then make it as simple as possible. Just not simpler. Just make sure you do automate things where there's a benefit. Get to know your environment and the possibilities. That's another IT point in a sense. But understand the software you could use, understand what the limits are. And when you come up with solutions, test them before investing a lot of time in developing them, because you might run into quite a few surprises as you go. And it can be a really bad thing if that happens late in the process. A problem I saw last time was that there is really too much to show in examples. And I've run into the same problem this time again. But I do appreciate that people wanted to see more examples. So I will show a lot more examples than we did last time. And to reiterate on the questioning, if there's stuff that you really would have wanted to see an example of, feel free to add that to the comments or the questions as well. If you want to ask for a specific example, I'm not guaranteeing we'll provide it. We won't do your automation for you, not for free anyway. But it's still going to be interesting to see what people would have liked to see result. I will give you a sense of what's possible, even though there's way too much to show all of it. And I've tried to keep it focused by not including too many different platforms. And then finally, key point that I wanted to repeat from last time, and from here on we'll just enter into new stuff, is try to configure things you make. And what I mean by that is, If you write a script and the script just does its thing and it does exactly the thing it's supposed to be doing, but all of the data is sort of like interwoven with it, it will only be useful that one time or for that one task, which can be repeated. That's already something, but it becomes a lot more powerful if you can extract the information that makes it specific to that situation in some form of configuration, which could be, just a couple of fields at the start of a script, or maybe a separate file like a JSON file or a YAML file, whatever you're familiar with. Because if you allow people to only change the configuration and reuse your script, it becomes so much more powerful. You can put it into the hands of people that don't really need to engage with the code or understand it. They just need to understand what the configuration is. If you make automation a part of your model and your workflow, not just an add-on, and you develop your model together with the automation and factor out information like that into configuration, you have a much better experience. All right, on AI, I won't rest with this too long, but design with AI. Use it to design and refine your automated process, not replace it. AI is not there to do the work for you. AI is there to help you design automation. You can use AI to automate stuff. One of our panel members, Shuang, might be able to tell you a lot about using genetic algorithms for model calibration, for example. And that's a good example of where AI can be very practical in model development. But that's not what I'm talking about today. I'm really focusing on designing with AI. And when I say AI in this context, I mostly mean the LLMs in the various ways we can use them. Generate codes, don't generate output. I'll give you the first taste of what I mean there in a moment. And play to its strengths. Code generation and code analysis suit LLM capabilities the best for the simple reason that it's formal and LLMs know exactly what the answer there should be. They still make silly mistakes and hallucinate or take a very long time to find the solutions you need. But this is their strong point, and it shows in all the tests that are thrown at LLMs. And stay accountable. This is the most important point. AIs can be wrong, they can be incomplete, they can be misleading. Whatever they make is your responsibility. If you use an AI to do the work, you have to be accountable for the outputs. So whatever it is the AI generates in terms of scripts or whatever, you need to understand that this is the key point here, because most of the rest of this presentation and what I'm going to be showing you is aimed at helping you understand a little bit better what the important parts are, what everything means, and what you should be looking for when you have LLMs generate scripts for you, because I make no illusions about, or I have no illusions about LLM slowly taking over and people writing fewer and fewer scripts and getting the LLM to do it for them, but you still need to fully understand and validate. All right. Actually, let me quickly show you what I mean when I say don't generate data, but instead generate results. Let's have a look. For example, if in TUFLOW, anyone who has used TUFLOW knows about PO files. They are output files, CSVs that had a time series of values. I could be lazy and simply go over to an AI and say, well, let's grab this PO file that came from the TUFLOW model run, and I can ask the AI to generate charts, the PO values over time. So that's good enough for it to come up with a chart of some form. That's nice. It'll probably do a good job. It generally does with this kind of thing. And it may use something that's useful to me. And I could take whatever it generates in a moment and use that in my reporting. But what do I really know? This is perfect, right? Like, this is exactly what I was looking for. So I can just copy paste this into my report, and we're off the races. Maybe, hopefully, I go and check that it's actually correct. It looks very familiar to me because obviously I've done this before. But a better question would be, generate a Python script that generates this chart. And it'll do that just fine as well. In fact, it'll probably output it quite quickly. I'm just going to tell it to actually skip thinking about it for longer, because I'm sure whatever it generates will be fine. I've done this before. This looks very similar to what I've done before. And I'll give you a quick view of that. Let's see. So the example I've got here, chart.py, is exactly that. Actually, I'm just open it up and actually we can have a look at it. So you can tell it's pretty much a very similar kind of thing. It takes that same file, it reads it, and it plots a chart. And of course, I can just run that script, right? So I can just go made a command environment for it, and I can just run this script. And if I run that script, voila, it's literally, well, not sure if it's identical, but it's very, very close. And obviously the advantage is I can now have a look at the code that is generated and see how it's done it, how it's gotten to this point. And that's my key point here. It's much better to have this because you can rerun this as long as you have Python, which you can always get. The AI might change over time. Very important point. All right, back to here. Got a lot to come through. This is only here to show you. I'll include some screenshots of stuff I've done as well. Let me know. No, never mind. I'll include these in the presentation that will be made available in a couple of days. So if you're interested in seeing some stuff that you've seen on screen and you don't want to watch the whole video again, look out for those. The command line interface. So pick the right tool for the job. The command line interface can be many things. It could be the command prompt, Windows PowerShell, PowerShell Core, Bash if you're on Linux. You could even consider Python or R to be more or less a command line interface. You have the interactive interface. A lot of people use Jupyter Hub and are used to using Python interactively. Whatever you pick, use it yourself. And what I mean by use it yourself is be in it. Right. So when I'm on a machine like this, I will a lot of the time will just be staring at this. I will just have it open with the command line interface at the ready and doing the work myself. And whatever commands I enter over here, this is what would happen if I was running it from a script as well. And actually doing all the work and moving around in here gives you a good sense of what actually happens when those commands are executed by the script. If you know how you would do it by hand in the command line interface, you know how to code a script. Don't learn by rote or don't think you need to learn by rote. Tools are often self-documenting and try to understand what you're running. So if you learn of a certain command or an AI tells you to run a certain command, give it a try or just ask it what it does. I was just running this command. If I really want to know what that does, I could just ask PowerShell what it would actually do. That gives me a basic idea of how you could call it. It's not very informative, but also can tell it just go online. Tell me exactly what the command is for, and it will load the relevant help page in a browser with a lot more background on what it does exactly. Try to understand any command you run. This is true on the command line. This is true in a Python script. It's key. There's also other tools, and I'll actually provide a link to people who are interested to this tool because I've made it available freely. I've even gotten to the point where I'm like, okay, I might actually just, how can I list? Oh, sorry. This is just a little Python script that goes and talks to the AI in the background. So instead of me just going over to the AI and asking it there, I like integrating it in places like these as well. I'm sure you're familiar with AIs being able to help you in a text editor like VS Code. But this is very useful as well. I'll provide this for you because all I can do to get people into using this CLI a little bit more, I feel like most of why people don't use it is they don't know what to do here. They don't know what they're actually looking at. I'll talk about it a little bit more right now. But to make it easy, I'll make tools like these available to you. All right. This link, by the way, is that actual project. I'm happy to take questions on that in the future. But it works, and it's exactly what I just showed you. Lots of commands are literally self-explanatory, right? Like you can, lots of commands will allow you to just ask for help. So I showed you get help, but there's also lots of commands like, for example, to start as another utility I'll get to. I can just type its name and hit $? And it'll actually explain itself to me. So I already know what it does. I could take this text and feed it to an AI and ask it to explain it to me as well. most tools are self-documenting. Interestingly, TUFLOW isn't. But of course, that's mostly because there's so much more behind those options that putting it all in a text screen wouldn't really make sense. And of course, TUFLOW is well documented in the manual. So look for command line options in there as well. I feel like really getting to know a tool, part of it is making sure you know all the options that it takes on the command line and understand them. All right. This diagram was in the previous presentation as well, except for the two bubbles, environment and security context. So I'll start with those. Won't rest on it too long. Let's quickly go on here. But I'll just say that the console application is really at the heart of automation. Shells, I'll talk a little bit more about those. Executables, like any program you run, scripts running on a scripting engine, TUFLOW itself, they are all console applications in that they take in text streams, they produce text streams, they read input files, they write output files, you give them arguments, and they produce an exit code at the end, and they operate within the environment in a security context. And this is true really for any application. But mostly the ones you use in automation are the ones that only do this. They won't have a GUI, they'll just do this. You typically engage with these applications through a terminal. So the general pattern is you have a terminal emulator, which talks to some sort of a command line interpreter, the CLI, which ultimately has console applications running into them. So for example, you could be using the Windows console host to look at the command prompt, to look at TUFLOW. The reason that's relevant is the command prompt is just a shell, and a shell is just another program like any other. From a shell, you can start other shells. And this is actually what happens a lot as you're writing scripts and you're running scripts. If you call one script from another, chances are you're starting a new shell for it. And that's one of the things I want to get into a little bit more deeply now. Let's see. I'll skip over this and get into this one right away. So talking about the environment is a set of inherited variables. That means that, and a lot of you have probably dug around in Windows and at some point seen there's something where you can set environment variables. These are variables that are set for your entire system. Whenever you open a shell or a console application, it will inherit a copy of the environment of its parent. So normally if you're running Windows, that will be Explorer. It has a whole bunch of environment variables set. And when you start a command prompt or PowerShell, those come into it as a copy of that. A console application or a shell can add to the environment. And then whatever it starts gets a copy of that environment. So it's a process that goes on and on in that fashion. Part of the environment, though, is also the working directory. And to my surprise, a lot of people don't really get that, even though I think it's one of the simplest and most important aspects of console applications. I'll just quickly show you something. Everyone's familiar with the Explorer, right? And everyone knows how to use it, more or less. You can navigate around by clicking a folder and you see what's in the folder, and you click a folder and you see what's in the folder. And if you do something in a certain folder, you can right-click and say new, and you expect that to happen here. That's what the working folder is, right? For the Explorer, the working folder is whatever folder you're currently looking at. That's true for any application. So that's true for a shell. If I start a shell, all it really tells me after it started up is what the current working folder is. And you navigate it in the same way. If I want to go up a level from the App-Velde folder into the users one, I just hit cd.off. If I want to descend into one, I just cd into it. CD, of course, means change directory. It's too basic for words, but so often have I seen people not really using the CLI to do this. The reason this is very important to understand is this is something you do in your script as well. Your script also has a current working directory. And when you write a script, you should know or have an idea of where it should start and then how it should move around from where it is. Anything you do within a console application is relative to that working directory, which is super important, right? The configuration files, the input files, the output files you're writing, it's all relative to the location the application is operating in. That's your working directory. Super important aspect of the environment. The rest of the environment, I might show you one or two more things. So for example, if I'm in a PowerShell, I can start a command prompt from here just by saying cmd, and I'm on the command prompt, and all the commands I'm used to work from here. And if I type exit, I'm back in the PowerShell. But notice how both of them say they have the same working directory, and that remains true. If I change into the 10 directory and I start a command prompt from here, it's still in the same location. That's because it gets a full copy of the environment from the previous shell. The way to look at it is, and I'll actually show you through a slide. The way to look at it is like this. The Explorer has an environment, it maintains it, and when you start a shell, the shell gets a copy. And then if you open a new shell, it just gets a copy from that. It only flows in this direction. So if a later shell changes something in the environment, that doesn't make its way back up the chain, right? So you can add and change things and expect them to work in new shells you start, the new console applications you start, but it doesn't mean you have to worry about changing anything in the system. As soon as you close the shell, you're basically back in the environment you had before. It doesn't bubble back up. Let's see. All right, the important thing to realize is if you use Python a lot, a Python environment is nothing more really than a whole bunch of environment variables that have been set. So if I load a Python environment in one shell and then I start another, I'm still in that Python environment because I get a copy of the entire environment. So you can activate a Python environment in a script, kick off some other script or some program, and expect that program to be running in that same Python environment, which means any packages you may have installed or anything like that will be available to it. So this diagram is a good one to remember, where environment always comes along and you add on to it as you go. I might get into a few more examples if people are interested, but I'll keep moving for the sake of time. A few things to note really quickly. If variables need to disappear, think about the word scope and ask about scope or search for scope. I won't go into that too much right now, but that's an important word to remember when you've had issues where you try to get some information from one script to another and it failed. It also depends on the type of shell you use. So pick a shell and stick with it, probably. Things work slightly differently between command prompt or PowerShell or Bash. And it can be very confusing if you're used to one using the other. You can write scripts in PowerShell just like the batch files most of you are used to. I'll get into quite a bit more detail in a moment. But one thing that people that aren't really familiar with, I've noticed, is the idea that you can source a script. So if you have a script, let's say I just make a very simple script here. Hello, the PS1. And I just go white host hello. Nothing fancy here, right? Like this is about as simple as it gets in terms of script. Then I can execute it and it, whoops, that's not what I was after. There we go. And, oh, oops. Jeez. They're obviously from a PowerShell. I can't do it from command prompt. This is what happens when you do stuff live. You start making mistakes. There we go. So that's what we expected. Let's see. Yes. So another way to execute the same script, and this looks kind of pointless, is if I put a point in front of it and then I run it, the same thing happens. So you might wonder what happens here. But this one period here is an entire command and a very important one. Doing what I just did is called sourcing. So dot and then a name of a file is pronounced source hello.ps1. The difference is when you source a file, all of the commands in that file are executed as if you just typed them. So it's as if I typed write host hello from the command prompt right here. Whereas when I start a script, it starts a new instance of PowerShell with a new environment and it runs the script and then it's done. And that means when you source something, if from that in that source script you define variables or you change the environment, you're changing it in the current environment for yourself. You're not really making that shift to the right that I was showing before in the diagram, but instead you're running the commands in the current environment. This is an important trick to remember. So just remember sourcing and the fact that it's done with a dot. I'm sure an LLM will be able to tell you if you forget. By the way, it's in the presentation, so you should be able to find it. And then an even further removed way of running the same process would be to say start process, a new PowerShell, and give the arguments. That really does the thing of starting a whole new shell and running the script in that one. So a script, when you run it, still has access to any variables you've defined. But when you use start process, it's as if you've opened a completely new window manually and started it there. It just inherits the environment you started from. So it's like 3 levels of closeness. Either you source it, or you run the script, or you start a whole new process. I think I already talked about a few of these. If people are looking for the command line options for TUFLOW, you can find them over here. I won't show you right now. And an important trick to know as well is to know what command actually runs if you run something. So, for example, I was running code over and over again. If I want to know what that command actually is, you can just ask the system. And if I do, it'll tell me, oh, that's actually this program over here. Because in PowerShell, everything you get back is not just a bit of text. You can kind of tell, right? Like it's a table, it's got several columns. It's giving you objects, so you can get to the attributes of those objects as well. If I just put parentheses around it, it's the same thing. But it allows me to take the whole thing in parentheses and say, from that thing, I'd like to know what the source is. And it'll tell me. So I can see that when I type code, this is the program that's actually being executed. It's a CND file, which, by the way, is another script. You could have a look at it if you wanted to. For example, by saying, get the content of that script, and it shows you exactly what it does. And you can try and understand this, and you can dig your way into how the system is actually doing things. And if you dig deep enough, you'll find that this code.x is actually just VS Code that I was running over there, but that's why everything works. So get command where, which, and whereas are commands on the various shells that allow you to figure out what actually runs when you type a command. Now, you can get programs to explain their options to you, like I said before. It's also important to realize that when a console application runs, it tends to tell you whether or not it's successful in doing so through an exit code. So if you run TUFLOW and the exit code is 0, it was probably a success. So the last command I just ran probably was okay. So the last exit code is going to be 0. But whenever that value is not 0, whatever ran before didn't successfully close. So for TUFLOW, for example, if it just crashes out for whatever reason, maybe some file went awry, or maybe a network share isn't there, or maybe you can't get a license, you'll be able to tell just from the last exit code, which is a very useful thing you can use in your scripts after running a command to decide whether it actually succeeded, or maybe you need to run it again, etc. Moving on. This is a biggie. So connecting applications with pipes is a big thing. Like I said, when you start a console application, if it asks you for text, really it's just reading whatever text you're providing it to it. You do that by the console. You do that by typing into it, and then it pushes out text, and that is what you see scrolling by. But you can connect applications to each other with pipes. So for example, if I look at the files in this current folder, let's just have a look at my profile. There's a bunch of files here. What if I only want to see the ones that have the letter D in them? Well, I could just take this list and filter it down somehow, but I can also just pipe the output and send it somewhere else to another program. For example, there's a program called Select Stream, and it just allows me to give a bit of text, and it'll only select the ones that have that in it. So I'll say D, and actually it cranks out a lot more because all the text that was there, turns out there's a lot more in the actual objects than what we were seeing here. And it's showing me everything that has a D in it in the objects that we were just asking for. But the key thing to understand here is getChildItem produces a stream of objects, and on command prompt that would be a stream of text, which I can pipe into another program that takes the output from this program and applies some function to it. A specific function you could apply to it is writing it to a file. And instead of using a specific program, you can just use a different symbol, which is a greater than symbol. And I'll just call it list.txt. And if I do that, you see that there's really no output. It looks like nothing happened. But that's only because all of the output that you're expecting to see has now ended up in this file. If I show you the content of that file, It's exactly what you expect it to be, namely the same output that would have ended up on screen otherwise, except it's no longer colored. And that's because, of course, we're now just looking at text. All those objects have been converted into text. And that's what this does. It takes the output from a command, takes its text representation and sends it to a file, which is very useful if you consider, for example, running TUFLOW and the output that it would normally send to the screen, capturing that in a file. Because if you think about it, you could look at that file remotely and see how TUFLOW is getting along without even being on the computer where TUFLOW is running. Now, if you still want to see it on screen, because, this is very quiet, that's where special applications like T-Object come in. And this is not something you have to install. Most of what I'm showing you is just standard stuff that's available to you on the PowerShell. If I T-Object and I tell it to write a file, list.txt, you'll notice that it still puts everything on the screen as well. What T does is, I guess the idea is like a golf tee, like you tee up the ball before you give it a whack. But it splits the stream into two. I'm teeing it and sending one stream out to a file, while the other one I'm not doing anything with. So the other one just shows up on the screen still. So I still get this list.txt, just like when I was redirecting. But I'm also getting the output on the screen, which is an important trick to remember when dealing with these streams. All right, I'll get back to my presentation here. So that's splitting a stream with a T-Object. There's a few minor things to think about because they do have a major impact. Streams are live. So when a console application sets something to the screen, you typically immediately see it or almost immediately. But an application can sense that it's writing into a pipe instead of just to what's called a TTY, a teletype, which is ancient history I won't bore you with. When I'm using a terminal, it's writing to a TTY. So you run something and it instantly sends it to the screen line by line. Even if it's millions of lines, it just keeps scrolling. It's what you're used to from TUFLOW. But TUFLOW is one of those applications that, through no fault of its own, detects that it's writing into a pipe. And when it does, it starts buffering. So keep that in mind. Sometimes it feels like when you set up a pipe, it's not working. Just give it some time, because once the buffer fills up, it'll flush it out and you'll still get your content. But it might change the timing quite a bit. So it can be a very tricky problem to deal with. Final point there is, think of a text file as a frozen stream, right? Like if you stream to a file, you can then take that file and bite it back into the next application. And it's like as if you've frozen the stream midstream and resume it later. I'll leave this for who wants to look into it, but do look into it. The example on screen would take a log file from TUFLOW and actually extract all of the timestamps from the computation with the number of wet cells. It might not look like it, but if you feed this to an AI, I'm sure it'll be happy to tell you exactly what it does and explain it in more detail. What regular expressions allow you to do is take complex text and filter out very specific bits with very clever rules, with very short code, because this is only a couple of lines and it does exactly what I just said. And the neat thing about it is nearly everything supports regular expressions. You can use them in PowerShell or command prompt, but you can also use them in Notepad++ for searching, or in VS Code for replacements, or you can use them in Python to say things about certain strings. It's a real superpower to learn about these. So do yourself a favor and Google regular expressions. And if you want to play around with them and learn about them more, I strongly recommend the otherwise free website Regex 101, no affiliation. With all that, I think I'll get into applying it, because we don't have much time left, and I really have something I want to show you about running models and loops, because this is the thing that most people kind of get stuck on or never quite get beyond. Before you get started, make sure you align with your IT. Like I said before, make sure that what you're trying to do can actually happen. Consider your own environment, but also consider the environment of who you're writing your scripts for, which might be your paying client or whoever takes on the work after you. Don't do stuff that makes it so you become the bottleneck in that whole process. Set up a new model with automation in mind. So add it on from the beginning. Version the model, like there's very good naming conventions defined on the TUFLOW wiki. But maybe consider using something like Git and GitLab to do that for you. If you're already familiar with Git and you make models, maybe you've never thought of the idea of applying it to your model. But I think there's real potential there, and I would give that as a tip. AI can be a great help, and it's at its best when you help it help you, right? So if you have technical problems, just give it that text. Get as much information as you can, maybe some source files, maybe some help text. Dump it in there and ask it about that, because it's the quickest way to get to your answers. And consider automating your model configuration. So most of you will write your model configuration yourself, but you could generate it automatically using templates, using the kinds of tools that I was talking about before to generate and modify those files as you create them. Let me just skip forward a little bit over here. I think this is the right time to have a look at loops. One thing I will say before we do is batch files are still fine. They're still right for some use cases, but I don't think they're right for serious automation. And we'll see in a moment why that is. Whether you should use something like PowerShell or Python, I think if you feel you need to use Python, you're venturing into development more than just a script. It's still Python scripting. Python is a scripting language, so I'm not talking semantics here. What I mean to say is that by the time you need Python to do your work, you should probably look at what you're doing as a bit of development and look at it in the way that whatever you're writing is something you're probably writing for others to use, but not engage with in a way where they have to change it, which makes you the developer, and it puts a really much higher bar on what you're doing with it. But I think the loop is a really good place to show what I'm talking about. So let's do this. All right. Just a simple example. Everyone is familiar, or everyone who runs TUFLOW at least, is familiar with this one. Let's see. This is common stuff, right? Like you got a whole bunch of runs, and you were smart and copied and pasted them, and so now it's really easy to see what's going on. You've got your 10-year and your 20-year, etc., and you've got your durations over here. And clearly, this is just looping through, basically just running these models one at a time, waiting while the previous one completes before doing the next one. Great, you can edit this. You can add in some lines. Maybe you generate it from an Excel sheet like some people do. This is the basics of the basics. One step up would be to say, well, I can just define a batch file that has a loop that just loops through those values. These are the same events with the same durations you saw before. But now I could just say, okay, I got some for loops, and I'll loop over these A's one at a time. Now I'll loop over the B's every time for each A, and I'll start TUFLOW with those values. Now, it's not really starting TUFLOW. I create a little tool that I use a lot, which is called mockflow. It just takes a TLF or a log file, and outputs it as if it were TUFLOW, because it allows me to quickly run something without actually having to run the model and wait for it. By the way, I can make that available to people who would like it as well, because it's very nice when you're testing this kind of batch file things. You don't have to wait for TUFLOW to start up every time. It's fast enough, but it can still be faster. And this is nice. You can actually find these, by the way, on the wiki. So the link that I was showing in my presentation, if you have a look over there running TUFLOW, it has all this information and a lot more on how to set up these loops using batch files and PowerShell. But what I want to get into is, like, even when you do that really well, you kind of still run up to the limitations of batch files quite quickly. This is nice, and you can do the same thing in PowerShell, and this is what it looks like in PowerShell. And arguably, that's not very different. And there's actually a couple of comments in here that we can just get rid of for a moment, just to get a fair comparison. This looks very similar. The arguments maybe look a little bit more messy in PowerShell. There's a little bit more stuff that you need to write to do it properly. The for looks very similar, so not really clear where the advantage is here. You might say, I'll just stick with batch files. But if you now want to do it something that's a little bit more fancy, And the website, actually, the wiki page goes into it. What if you wanted to run 3 models at a time? Because let's say you're running this on a computer that has 3 GPUs. Lucky you can run 3 models in parallel, all on a GPU. What the website proposes is to do something like this. And this is literally that code. I've adjusted it so that it runs my little program, but it's literally the code from the website. Again, same data, but now it's saying, I want to run 3 at a time. Let's set a counter and start. Every time we start something, first we increase the counter. And if the counter reaches 3, because that's the number we set over here, we'll actually make the system wait until that run is complete before we continue. And then once we continue, to set the counter to 0 again, so it can loop back and start another one, 1, 2, 3, and then has 3 running. This works fine. I can run this. I can loop like that. If I run it, you see what it does. Like it runs TUFLOW, not really TUFLOW, it's just mock flow, 3 at a time until it's done. And I'll just stop it from doing that because I don't need to see any more of that. Yep. That's great. You can do the same again in PowerShell. And to do exactly the same in PowerShell, we end up with a bit more code, although it might be a little bit clearer what it's actually doing. But there's a real problem with this. And by the way, I'll just illustrate. If you go over to something like ChatGPT, just start making a chat over here, say, what's wrong? Just tell it to be quick about it. Don't have time to wait for a good answer today. It'll pretty quickly point out, there's a problem with the throttling. Because what if that third run is very quick and the first 2 are running for very long, and you were counting on there only ever being 3 running at a time because you only have 3 GPUs? Now you have a problem because the third one completes, which means it starts a new third one, and then a fourth one, and then a fifth one before it waits again. So now you have 5 models running on your 3 GPUs, which is going to be a serious problem. So it's really not that good. It's quite clever the way it works. And if all your models are sorted, and to the credit of whoever wrote it, they are, because obviously as you get into longer durations and more rare events, the model run will typically take longer. So what I just said might happen. It's not very likely to happen, but what if it just runs into a problem for a specific event and it crashes out and then it starts to more? Now your runs are messed up. So you'd really like something better. This is where batch files and PowerShell part ways. In a batch file, it'll be very hard to write something that's a lot more clever. Not impossible, but very hard. And actually in PowerShell, not that much harder. So this is a very similar looking script where there's still this loop. I've renamed things a little bit to avoid problems, but I still have my events and the durations. It's looping here, and most of this is just comments, right? So really all it does, it says, if there's still jobs running, then wait for any job to complete. And when it's done, just receive what it's done. And for now, we'll just throw that away, but you could do something with the output. This would just be the output of your TUFLOW screen. And then start a new job and tell us that it started, and then start over again. So it still counts, still got P over here, still limiting it to 3. It's still looking whether the number of running jobs is less than 3, or rather it says when it's greater than 3, wait for one to complete. Greater than or equal is what it says over here. So it's basically starting 1 job, 2 jobs, 3 jobs, and then it's like, oh, I need to wait for one to complete. Waits for one to complete, doesn't matter which one, and then starts a new one and keeps doing this until it's done, until it's started all of them. And then it'll sit over here, wait for all of them to drain out, and it's done. This is fewer instructions, and this does exactly what you want, because this only runs 3 jobs at a time. And I think this is a really good example of why PowerShell gives you a lot more power to do this kind of automation and get much closer to what you actually wanted, instead of approaching it with a batch file but not quite getting there. Just to show you that actually works just fine. Actually, I'll use the sourcing thing I said before. So instead of just running the script, I'm going to source it, which means that the jobs that's being defined over here will be defined in my environment. So I can have a look at it once it's done. So here we are running it. And so you see, it's just starting jobs. It started 3 and then it had a bit of a hesitation because it was waiting for another one to complete. And I was just slowly ticking through all of them. It started them one at a time, clearly taking its time because it's only running 3 at any given time. Once it completes, which should be pretty soon, it should have run all 25 of them because there's 5 times 5, right? So, yep, there we go. It's all done. Now, if I have a look at what jobs is, there's 25 things in jobs. And if I look at the actual values of it, those are all jobs. And PowerShell is telling me, okay, they're all completed. There's no more data waiting in the pipe. They're still around, though, so you can see that they ran. And I could just go and just remove them. I can actually just ask PowerShell as well. I can say, get Joe. And it'll say, well, these jobs are jobs I recently ran. This is stuff that doesn't make it into batch files at all. It's pure PowerShell. All right. I've got a ton more, but I don't have any more time. And I keep running out of these things. I'll speed run my way to the end. There's if someone wants to really see it, like the really interesting example of how you can see what current licenses in use are, we'll definitely include that in the handouts that we'll be sending around anyway. So if you're curious about that, just have a look at that. From data management, there's a few points I'd quickly like to make. Have a look at TUFLOW FE's get tools if you're an FE user. They're great not just because they do what it says on the tin, but they show a way of running your models that I think should be more broadly considered, which is to get the data when you need it, where you need it, using tools that specifically get it directly instead of being a human about it and moving the entire model around with everything that goes with it. You have to keep in mind that when you start automating, you need to use the strength of the automation, right? Like your scripts can really focus on certain files really easily or do really complex or laborious things in almost no time at all. A similar example is this little tool over here. It's called Pizza. It spells out by PY7ZA, but since that's impossible to say, I've called it Pizza because it kind of looks like it. What it does, it'll zip up your files, but instead of zipping up all your files, it zips them individually, which has the benefit of still allowing you to find the files you need or only selectively compress them. It's another tool that does a job that's manually almost impossible, but with a tool becomes really, really easy. There's a whole bunch of other tools that I would recommend you use. I won't get into them right now because I think it's long overdue to get into some Q&A. Thanks for your attention so far. Sorry for the crazy speed run, but like I said, there's way too much to talk about here, and there always will be. Really happy to take your questions at this point.
Yeah, thanks, Jaap. Really, really interesting. Actually, a little bit quieter, just on the question line than usual, probably because people were in awe of what you're up to. Did get a little bit busy towards the end. I think one of the most upvoted questions was, many users of tools that I wrote aren't comfortable editing YAML or Python configs, so I end up building GUIs. These help, but they add development and maintenance overhead. Do you have any tips for enabling non-programmers to adjust configs and run scripts independently? It's from Henry.
Yeah. It's a really good point. I think in part, a decent editor, especially one that makes use of some AI, could be a really big help there as well, right? Like if you use something like VS Code, and you can just ask Copilot, like, hey, I need to change this thing, but I don't really understand this format. Those kinds of editors can really help people to quickly learn to understand these formats, because I feel it's generally just a little bit of a speed bump. It's not that writing those kinds of configuration files is truly hard. It's just that it's kind of programmy, and you really need to get into it. So using those kinds of tools can be really helpful. I don't think there's anything wrong with writing a GUI for it, though, if you know the format is fixed, because then the GUI will not have to change over and over again. If you're really clever, you could generate a GUI around it, but I think that's maybe best left to the people that get paid for it. And then at that point, you might be looking at more specialized editors. But yeah, I think putting better tools in the hands of your users so that they can actually engage with those slightly more complex files might be the best way to go there.
Excellent. Thanks, Jaap. As someone with a non-coding background, is GPT-5 a good AI for creating codes, or are there some better AI models for better results? I know you've got some opinions on this.
I've got some opinions on this. I will say I was using ChatGPT in the example, A, because I think it's the most common one. B, because I happen to have a paid subscription for it right now, but I've jumped around a little bit. If you don't pay for any of the AIs currently, there's two things to consider. One is, what are you going to be using it for exactly? If it's just for coding, right now, I guess I'd recommend Claude. It's really quite good. But things keep changing from month to month, and they're all quite good. So I don't think you can pick a bad one. It's just that some of them are slightly better. I like Claude because it gets it wrong the least, which I think is an interesting way of qualifying them. The other thing you should think about is what your company will allow or is willing to pay for, because you could pay for it yourself, but if your company is already into, say, Copilot because it's really into Microsoft, it might be worth just picking that, or at least giving it a try for a while, because they're more likely to approve of you actually using that in your work. Because keep in mind, these tools, they do take your data and process it, right? So you can't just stick anything in there. So I think that's an important consideration as well. But yeah, if it's just what's the best for code, the one-word answer right now is Claude, I think.
Excellent. Thanks, Jaap. This one actually might be one for you, Shuang. I've heard that AI is being applied in model calibration. I'm curious about the extent automation provides focus on multiple scenarios, or does it go further than that? I know, Shuang, you've just been involved in some genetic algorithm calibration.
Thanks. Yeah, I typed the answer, but yeah, I guess it was while answering as well. Yeah, so we've been attending like hydraulic related conference in Australia and internationally, and we do see lots of like pickup in AI or like machine assisted model parameter calibration. So yeah, in most of this study, you just write the script and run TUFLOW or any other software and get the result and compare the result with observation. And from there, you use some kind of algorithm to pick the next model parameter set so that the model result will become better and better for your model calibration. I think PEST is a really good example. I think it's it used a lot in the field of groundwater model calibration. We've applied genetic algorithm because we attended a keynote speech during HWS conference last year, and yeah, it's been showing like very promising result that can like help you improve the efficiency of model parameter calibration, especially for model with like lots of model parameters. So yeah, it's an interesting field to work with in the next couple of years.
Excellent. Thanks, Sean. I am conscious of time. We'll probably wrap that up with one last question. Jonathan Clarick, the CLI tooling is usually better on systems such as Mac OS, Linux, and even WSL. I think, Jaap, you had this on one of your last slides. Does TUFLOW work on those systems, or are there any plans to make TUFLOW work? The answer to that is yes, there are. So TUFLOW FE, the flexible mesh 2D 3D solver, does work on Linux as well. And we are in the process of porting TUFLOW Classic HPC across with a target of the 2026 release. So hopefully over the next couple of months, we'll start to see beta versions of Linux TUFLOW available.
I think that's an amazing effort that you're a very important part of, Phil. So thanks for that, because I'm excited about it. To add to that question, though, or to the answer, I don't think it's necessarily true that those environments are better in the CLI space. Especially with something like PowerShell, I feel like Microsoft has really stepped up. And actually, if you feel like investing some time, PowerShell is available on Linux as well. But you're right that they are more focused on that, right? Like many Linux servers won't even have a GUI. So the only way to engage with them is through the CLI. So I think making yourself more familiar, working in a command line interface, you'll find that actually they're all very similar. Small differences in exactly what commands you're using, but the concepts are always the same. The things I was talking about, they're not specific to Windows. They're true across all operating systems, whether that's ancient Unix or Windows 11 or your Mac OS, it's all the same. All these processes, all these ins and outs, they're always the same. So once you understand it, you can use it, and you can transfer those skills and run on cheaper and faster Linux as well.
Excellent. Thanks, Yap. Yeah, much appreciated. And yeah, thanks a lot for the presentation. I certainly found that really interesting. Just a reminder, there are some questions that came through just at the last minute. We will go through all of those and get an answer to those and send a follow-up in the next couple of days. So
Sure.
yeah, thanks everyone. There will be a short pop-up that comes up and also just a plug for the next TUFLOW webinar, which is coming up early next year about certainty about uncertainty. All right. With that, I think we'll wrap it up. Thanks, everyone.